Bridges is an interdisciplinary program because students in our program learn best by being exposed to repeated content and to language functions and forms. People learn best by doing, and this is also the case in science. By having our students participate in hands-on, authentic science inquiry, they're exposed to the nature and practice of science. First, take a look at the course narrative. You're able to see our overarching goals for the science course, our philosophy and our rationale for why we chose what we did for students for this discipline. From there, we will then suggest you take a look at the curriculum map. Here, you will actually see more about the content and the skills and how they are weaved throughout the units. The Bridges Science course has two essential questions. The first one is, why is food important to our lives? And the second is, how and why do we learn about food in science? The essential questions of the course guide the learning that's going to be taking place within that. These essential questions may seem basic at first, but they are because we want students to be able to relate to them, and throughout each unit, students will be able to answer these questions in a more scientific, a more academic way. We know that all students have some type of connection with food. Obviously, we eat food every day, but some students might have experiences growing food, preparing food, selling food, but then also using that as a vehicle to explore more about the scientific concepts behind food. This unit draws heavily on the skills of observations and then being able to sort and classify objects based on those observations. We also look at how you can represent food in multiple ways by illustrating it and drawing it, writing about it, creating data tables and counting and showing their data in visual representations through bar graphs as well. We suggest that you move on to the unit maps. Here you will find the lesson goals, the aims, the essential questions of the week. You will find the vocabulary and the actual text that we'll be reading and the materials that we'll be using. The course, it has 4 units, and each unit, it culminates in a performance test. These tasks are very scaffolded throughout the unit. The students have multiple opportunities to practice the skills that are embedded in these tasks. And then a week or 2 weeks of the end of the unit is dedicated for them to work collaboratively and individually on this performance task. It's a chance for students to showcase what they've learned thus far. It's a chance for them to present to each other, to evaluate their work, to evaluate the work of others. It's a culmination of everything that they've learned in the unit. Within the unit guide, each set of lessons has a designated page that explains the language of the set of lessons for teachers to use when they're planning. We try to build students' vocabulary from a basic to a more academic level. So for instance, students might begin by saying what they see. I see that this apple is red, and then eventually replacing that word see with observe, so more scientific, more academic term. For some languages, we also offer a resource that is a bilingual PowerPoint. Essentially, this is a glossary where students, teachers, parents can look to acquire new vocabulary and new understandings of some of these larger abstract concepts. Observations are the fundamental starting point to any scientific inquiry, and we continue to build on and develop these skills throughout the course of the unit. Our goal for this course is to have students become proficient in these skills such as observation so that they are able to conduct authentic scientific investigations. we wanted to give students the opportunity to build a foundation in science, content, and skills that would best support them for whatever class that they enter in after this, whether it be biology, chemistry, or science. These identified by the Next Generation Science Standards include those skills such as making observations, classifying, making inferences, constructing graphs and interpreting data, being able to ask questions, communicating the results, how systems interact with each other, cause and effect relationships, and then also the structure and function of parts, how things work together as a whole and how they function individually. Within each unit, we have multiple assessments that we give the students. It begins with a pre-assessment that we offer at the beginning of the unit. And the intent of this is to see where kids are starting from, what they're coming in with, their content, their skills, their language. We understand that our students come in with different experiences having taken tests. Some of them haven't taken many formal tests at all. They've never sat down and been asked multiple choice questions or fill in the blanks. Other students have taken plenty of tests and have been frustrated over and over again. This pre-assessment will also be repeated at the end of the unit in the post-assessment as a way for us instructors to measure their growth. Developing the Bridges Science course has been a collaborative effort among many members of our team, which includes science teachers, science content experts, curriculum writers, linguists. Right now at 2016, we are halfway through with this curriculum with Units 1 and Unit 2.